Morning, Rita.
What's up?
Great. How's it going?
Well, Nautilus, it's a pain.
Bad?
Sorry?
I was greeting you, asking what's up on your end.
Ah, uh, I'm immersed in Nautilus stuff, finishing the new preamble, the new frame format for Messenger V2. On wire encryption is ready, but we extended the scope.
Extend the scope. Okay. Uh,
Yeah,
okay.
that's always the story.
See.
Initially, it was on wire encryption. Then we decided, well, if we are going to make V2 with encryption inside, maybe let's use the protocol to be more friendly to encryption.
Okay.
Long story.
So we have a Rukon here as he's on vacation. So let's start from myself. In last week, I think the Chrome OS boot up is pretty in good shape, as it's able to keep alive from his peers' point of view, and his peer want to mark it down and out. As a heartbeat support is around, and the put message is the the address input message is correct. So neither the its peer or its the monitor won't drop the connection when they see the message enclosed in the the addressing message is wrong. Now it's get corrected by the recent change on Chrome OSD, and I think that what I was working on in last week, and then another surprising is that I found that it's not enough to inherit the memory store. We still need at least partial support of the recovery machinery to put the to not put the OSD but to activate the PG. So it's so the peer OSD and the monitor will be get updated by the most up to date PG information, PG mapping. That's that's a that's a little bit surprising to me, but I think we need to come up with a solution to bite the bullet sooner than later. And I'm working on it. And regarding to the workload, I don't think it's a trivial work. It would take probably more or less than some a week or so. And that's me. And Chame, how's it going?
One minute. So you mean you currently boot multiple OSD instances, right? Can you hear me? Oh, I can't hear you.
Oh, sorry, I muted. I can hear you.
So
How about now?
you found we need to do the PG peering. So it means you boot multiple OSD instances, right?
Yes.
Okay, so you have given me the comments, and so I want to discuss with you how to design the OSD architecture based on the I/O
Yeah.
path.
Yeah.
So for the QoS, I think if we don't use Q, I have no idea how to support the QoS without Q. And since the OSD also supported something like request priority and some other weighted priority, so that means we should use some Q to do the QoS and the priority. Do you agree that?
Sort of, but I need to do more research on this area. But I kind of agree with you. But I always thought that I we I think we've been thinking how to work out a model to support the run to completion. But if we use a queue to queue the request, it's it's not a run to completion anymore. Am I right?
I don't think a run to completion means not use queue. So Scala DB also use
Hmm.
some queues. Not means we use queue. So run to complete is not the.
I don't really think we should use SeaDB as the proof with more investigations.
So for example, I give the example, if we don't use the queue, we still need some
Hmm.
queue to include the promise. For example, if we need to wait some OSD map to
I
update.
mean, if 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 a request is not blocked by a certain precondition, so we include it in the queue and then pull it out of the queue, like some kind of worker thread.
So if you mean if the condition, all the condition is meted, is satisfied.
Is
So
met, yes.
I think only queue we needed, I think, is for the priority or something, the QoS for that. Only that queue, I think.
I think we need to do more investigation on that in that area. But my gut feeling that we need the queue for supporting QS, but I cannot be 100 confident about it.
So you mean without queue we can support the QoS, something like priority and something the
No,
QoS, right?
I cannot claim that it can or cannot without more
Okay.
investigation.
Okay. So
If you have done your research on this in this area, I'm sure you will be convinced about it. But I didn't do. But I haven't seen your comments in this area. Aside from that, CLDB also do it, but the CLDB does not claim that they are doing run to completion or or we or we are trying to mimic CLDB in any ways, other than we are using their SeaStor framework.
so okay, I will do the investigation on the if it is can we
Yeah,
implement
that's
the
why
QoS without
I
queuing?
suggest you to send a mail to the mailing list for more input before we made any big decisions. For example,
Okay.
Greg has raised his concern regarding to the Q usage in Crimson OSD.
So that is for the all condition is satisfied. So the request should run
Yeah.
to complete without queuing. That's your opinion, right? And we without
No,
queuing
no,
and
I don't have an
implemented.
opinion, but I
Okay.
I
Uh,
I'm only suggesting that we need to do more investigation and put all the facts on the table. Make sure that we have explored all the options before we go to the answer.
sure.
I
So
just
I
kind
will
of
do the
afraid that we are
investigation.
we're copying the existing implementation in the existing OSD.
And for other cases, the condition is not satisfied.
Mm-hmm.
So we queue the promise or we queue the request. I mean, do you understand my
Personally,
meaning?
I think it's pretty good.
For example, I want to give the example. If we're waiting for the OSD map update, the OS map is old, it needed to update, and we should queue some promise information. When the OSD get the new OS map, we should call the promise set value to trigger the futures to run continue, right? We have to save some information like that.
I think that's exactly what I suggest in the mail I sent it to the mailing list and you.
But you didn't mention any queue.
I mentioned that we need a container or map to keep track the continuation or the all the pending requests.
So it's still in. You mean it's still in queue the request or in queue some promise?
Yes, it's not a necessary queue anyway, but I don't think this matters.
So in queue the request also acceptable. Means we still need some queues to in-queue the request, and then when the condition is satisfied, we re-dequeue it. Or you mean we just
Yes, I sort
in-queue
of
the
agree
promise?
with that, but we
can just in-queue the promise, and then we needn't schedule it. We just when the condition is ready, we just call the promise set value to trigger the future, and then the SeaStor schedule will reschedule it. But if we in-queue the request, it's for us to reschedule the request from the queue.
yes.
So which one you prefer?
I don't have a strong opinion in either of these this option. I'm trying to understand the benchmark of performance. Probably we need to do some micro benchmark on the on the raw request queue and the continuation queue in the reactor, as suggested by Greg.
But
But
even
my
though
gut
we use
feeling
reactor,
Bigger.
well, so even
Hello?
though we use the reactor stack schedule queue, we still need some in-queue or in-queue option in our code to in-queue the promise to record which promise need to be triggered when some condition is ready.
Yes. I think
So
you are repeating my last email. I think I sent it to the mailing list, and we do need a container to map the condition to be met to the continuation or to the promise we are not yet able to fill when the request comes in.
Mm-hmm. Okay, so
it's difficult to say that which one is better without micro benchmarking. It's not pure win on either side, right?
But so because InSyn's case is very simple, so they just use the send queue to do the send in the batch.
Yeah.
So that queue give a better performance.
Yes, I think so. You mean the queue in the application, right?
Yes, so Yinxin has a send message queue, I think. But that send message queue function is very simple, not so complex. So the performance Yinxin get is better when you use a queue. And for us, I have another concern is that when we need to keep the order in the same PG, and so the existing OSD use same different stage. In different stage, they use different mechanism, something different queue, different lock to guarantee the ordering in the same PG. So that lock will not be held for a long time. So it is divided into different stage. If
I think you did send the mail for discussing this kind of a PG lock or PG queue in PG, and Greg replied that we can have a object specific queue.
object specific queue.
Yeah. Do you recall that?
Not yet. Object specific queue.
Probably I was using the wrong naming, but that one
So my
Greg
opinion is
replied on your
my
mail
opinion.
on this.
But anyway, it doesn't matter because OSD for the PG lock, it hold in the whole OSD layer and the PG layer.
Yes.
So it's only one lock here, and not influence much for us to decide now.
Yes,
So
not block at this moment, as long as it does not impact the overall architecture. Does
so
it?
do you have any other opinions except the queue? So I just keeping the existing OSD layer concept, OSD layer, PG layer, and OS layer, and the condition check, when to check the OS map, when to check the PG, and when to check the connection features. And so, do you want to reorganize this concept, or you just concern the queues
I think
we used?
it depends on the scope of this apple-to-apple comparison project. I take it a short-term implementation or prototyping of a Crimson project, and I don't really want to drop all these code on the floor once we want to move to, for example, to design. Either we want to have a one-to-one mapping or M-to-M mapping after we have the one apple-to-apple comparison. If we just want to use what we are working on for the apple-to-apple comparison and throw it away, it's fine. But if we want to reuse a general architecture and the model we are currently using, I think we need to put more thoughts on the overall architecture and the design instead of just reusing the existing OSD without rethinking the threading model and the interfaces.
I can't understand. What's your opinion about it?
I think it depends. If we decide
Okay.
that we will throw away whatever we have after we have an apple-to-apple comparison and get a benchmark number, it's fine. It's fine how whatever we want, whatever model we are using. But the bottom line is that we need to make sure it's represented the optimal benchmark result we can have using the the SeaStor framework. That's the bottom line. But if we just reuse whatever the threading model, the existing OSD is using, my concern is that we are not going to have an optimal benchmark result. But I cannot sure if on the other side, if we decided to reuse the overall design and the code what we have after we have the apple-to-apple comparison, we do need to be to put more thoughts on the overall architecture and the interface design.
So what we should do now? We just the first step is to do the POC and to do the performance testing.
Yes, but I think the bottom line is that we need to make sure that the performance will be present what we can have with SeaStor. But Chen-Mei, are you sure that the Q model is optimal, can get us the optimal number of the apple-to-apple comparison? If you are sure, we are good. But if you're not sure, we need to put all the alternative on the table and think about it before moving further.
For me, if all the conditions, my original opinion is that if all the conditions satisfied, so only the first queue we used for the QoS and or the priority we citing in the request, because I don't know how to implement the QoS and the priority. We should use the queue to help us to implement it. If there's some condition is not satisfied, they need to trigger the continuation later. So two choices. One is we use a queue. Another one is we use the at least to save the promise.
But Chen-Mei, I got a question. How do we use queue in assuming that we are going to use a queue for all the for the request? How shall we use SeaStor to have a queue to check the request in the queue?
What do you mean to check the request in the queue?
How do we have a queue? Have a task running in the background in SeaStor?
SeaStor, you mean the SeaStor itself, the schedule queue? So,
what do you mean by schedule queue?
So when the promise is set value, the task with the attached to the promise will include the scheduler by the SeaStor. So then that task will be scheduled again. The continuation will be scheduled again.
So you are talking about the task queue in reactor, right?
Yeah. Yes. So that is task queue in reactor. We only need to hold the save the promise. When some condition is ready, we need to know which promise needed to set value.
I think we are talking about the queue for supporting QoS, right?
Yeah. So
in that case, we cannot use the queue in SeaStor.
Yes, we don't use that queue in SeaStor. We schedule in our code. We put it in different queues. We have the algorithm to calculate which queue should be the queue first.
So how can we dequeue an item using a background worker thread like we have in existing OSD.
Oh, we have a loop there. So we have a loop to check until to request to dequeue the request until the queue is empty.
Okay. Anyway, probably we can discuss this later offline.
So
I think the gist is that we need to put the fact and have it discussed instead of just go to the answer.
okay, so you signed I replicated the existing USD. So you mean I use the queue, or you mean I use the existing layer division and some
Both of them.
So what do you think the other concept? So I keep the current layer division and the business logic check. So do you think we should modify?
The way we model the way how we model OSD depends on how we model this. It's based on the threading model of OSD. For example, we have the PG shard OSD, where we have that's why we have the generalized queue event and PG queuable items. That's how we model the tasks consumed by PGs. If we are going to use the same model, threading model, we will need to redesign such kind of object queue or work item. Do you agree? It's not separable. It's not two things. The threading model and the class architecture are actually coupled with each other.
The queuable the item means there are different requests. There's OSD plant to the OSD request. Still have other queuable items such peering items and something like that.
Right.
We should support all of the items, right?
I think so.
So why? So what do you mean? We should we keep the current division of the items type.
I don't have a I don't have an answer for this. I'm just trying to explain that before we have a before we design we need to put some thought on the model we are after before we copying from the existing OSD. For reference, our goal is not to port OSD to Crimson or to SeaStor.
So what do you suggest I do now? We don't have answer.
I think
what we do.
I think the way to forward is to put the critical design. If we are not fully convinced, we need to put the question on the mailing list and have it fully discussed. At least we can leverage the community to have the problem on the table and have more eyeballs on it, in hopes that we can explore all the alternatives before going to answer. The bottom line is that we can copy from the existing OSD, but I don't think we should just go for it. For example, if if a request all the preconditions are met, probably we can figure out a way that it don't go to a queue, or we need to ensure that even if it goes even if that request goes to a queue, it does not need to be switch out and switch in the SeaStor fiber, and it can be directly consumed served by whatever PG it's targeting. So I think probably the first step is to put all the discussion and the pros and cons on the table and send to the safe devel. Or if you are not comfortable with it, we can discuss offline. But I really suggest we can.
Yeah, okay, no problem. I can raise the question in the community list.
Yeah, because I think Greg has some concern regarding the queue, and he has done some groundwork on the sharded data structure in the OSD. So I guess he has some insight in this area.
Okay, so no problem. I will raise the question tomorrow. And collect
I think you, in the meantime, probably you can take a look at the for example, the MakeFS support. I think it's not critical, but it could consider it as a warm-up project, mini project for you to get along with the to get familiar with the Chromos OSD, how to put it out and how to replace it with the existing OSD in the VStar cluster.
It is already supported in your code. I saw it.
It's not support. It's the overall architecture is ready, but it's not supported.
Oh, what do you mean? It's not supported. The code is already there.
It's not tested. For put it another way.
Oh, it's not tested. I see.
Okay. Well,
it's not tested.
The tested part is the boot up and the heartbeat.
Oh, you didn't mount the memory store.
I
you
do,
didn't test it.
I do. I tested it, but the MakeFS support is not quite ready.
Okay, I see. Got it.
Chromos OSD is not able to create it. It's not able to create a store.
Not able to create a store.
I'm going to with the command line.
Okay, I see.
Okay. 建鹏.
I warm up the MSGRv2 code, and there is a question.
Yeah.
Current the Crimson message work well for MSGRv1. Why we move to support MSGRv2?
Good question. Because we are going to
So for the performance testing, V1 is enough, right? The V2 is low priority.
Yes, that's a good point.
So we can support V1 completely first. And Jianpeng, can we do the multiple connection testing now? I'm not sure what Yingxin test is one connection or multiple connection.
I think V2's implementation is highly important, but the priority at this moment is relatively low.
Yeah, so that Jianpeng and Yingxin make V1 fully supported first, and we can get multiple connection testing
No,
result.
I don't think we need to fully support V1 because as long as it's workable, we don't need to support all the features that V1 supports. For example, the lossless connection is still broken, but I don't really think we need to implement it at this moment. I don't think that we need to support it ever.
So do you think the V1 support now is enough?
For the Apple to Apple comparison, I think it's actually it's workable.
It's workable, and
Yeah.
it's enough.
Before it's not enough, it's enough.
So Jianpeng, can you make sure?
It's good enough at this moment. Put it that way.
So then we can
Unless
get the multiple
we find some problem
connection.
in it.
So Jianpeng, the testing result is one connection or multiple connection from Yingxin.
One connection.
So can we get multiple connection and to make the comparison?
Okay, we can test before the. I think there are a lot of change after my test occurred. So can I retest the code? There is other question. If MSGRv2 conflict, how to handle the MSGRv1 drop or they both exist in the code?
We can leave it around and or drop it either way. The V2 will be dominant. Will be the dominant protocol in SAFe in the next release. But we need to support it for talking to the client, I think.
Okay. The other work I last week is in the email you mentioned the batch handle send message. I test the performance and compare the roaming's performance. I think my PI's performance is not improved much as roaming's performance, but roaming's performance has a limit. It only support POSIX stack, but is only support TCP. But for DPTK and the RDMA, it don't support. So
I think Jianpeng. I think one of the benefit of Chromosome project is that it can also benefit the existing OSD. So do you think it's worthwhile to enable the existing async manager to fetch send the message? Put it that way, I think it could be helpful if we can get this feature before knowledge, and that you can work with the roaming to get it merged.
Yes, I think it's worth to do this.
And regarding the current OSD, I think I talked to some of the SeaStor developer and the SeaDB developer. They are mostly working with with a POSIX stack instead of DBT stack or the native stack. So I think putting another way, the batch send will very likely to benefit to the Kubernetes OSD also, even as a native stack are not likely to be used.
Can you repeat it? I can't follow.
Sure. I talked to some of the CLDB developer and asked how they are using their native stack. For example, the DBT stack and the native TCP support, native TCP/IP protocol stack. They mentioned that they are very happy with the POSIX stack. So my understanding is that because of the ecology of the TCP/IP stack and the DBT stack, it's poorly supported by multiple tools in Linux, unlike the POSIX TCP/IP stack. So my gut feeling is that we are very likely to be using the POSIX TCP/IP stack. So your
you mean
change
for the POC, we only support the POSIX stack. It's okay, right?
Yes, and what I'm trying to say is that in long term we are very likely to be using the POSIX stack also.
Okay, so Jianpeng, just focus on the POSIX stack.
But DBT is Intel product.
It doesn't matter. We do the POC first.
Okay.
Sure. I just wanted to lay down the facts of how the upstream what's the upstream's opinion regarding to the native stack.
That's question. Except the TCP/IP stack, there is a RDMA stack.
Just consider POSIX first.
No, RDMA is not POSIX. It's
But your change only existing in the POSIX stack, right?
No, I changed don't affect the low layer stack, but Roaming's PR affect the POSIX stack. So the performance he's better.
Okay.
So you mean the Roaming's PR means that they modify the kernel TCP/IP stack?
No. He moved the TCP stack into the protector layer, so the performance is better, but it's
kind of hack, right? By exposing the internals of a TCP stack to its upper level.
Yeah.
To the abstraction level of the stack. Okay, that's nasty. But do you think we can encapsulate the kind of change in the TCP/IP stack?
I think we can try later. I can try. I can try this to make this all apply to all stack.
Yeah, but if it's not too risky and intrusive, probably we can just get your change merged and. But it's up to you, I think, to evaluate the workload and how it is risky to the existing project.
So that PR is already merged?
No.
No.
Roaming's PR don't send to GitHub. I think he only sent the URL for the page. I think he noticed this question. It's only for the POSIX stack and not for the RDMA or DBDK stack. So okay, that's our work.
I will also ask for Mark's opinion regarding to your change and roaming's change.
Okay, thanks.
And Radek, I think you're pretty much occupied by the Messenger v2 encryption support.
That's true. I'm working almost exclusively on V2 on Nautilus-driven features. If somebody is interested, there is the ongoing pull request with that brings support for on-wire encryption for async messenger, but also implement a new format of our frames on wire. Basically, a lot of changes. What might be what else? What may be interesting for SeaStor is the story with buffer list. Right, the reader suite tautology showed that in hypercombining we've got an issue. However, fortunately for us, a small patch that disables only the hypercombining seems to work. There was no need to revert all changes like the zero, like the atomic operations optimization or filling up in buffer.
So we are basically disabling the hypercombining at the compile time instead of reverting
Yes.
it as a whole. Okay.
Exactly.
That's nice.
We are not using the placement, the terribly placement new. There is an issue. I've got a local reproducer that kills CEF monitor immediately, but well, just workarounded the problem and switched back to V2 stuff. Anyway, it's almost sure it's a lifetime issue between the hyper-combined buffer pointer and its underlying row.
Hopefully we can get you back once the notice is out and the feature is stabilized.
I hope so. To be honest, I really hate the new code or the messenger. Well, it's a mess at the moment.
I see. Understood. And any questions regarding to the next step and the state of the call?
From me.
Okay, cool. Talk later, Trime. I think what we need is to lay all the facts on the table before we'll dive into the details of the implementation.
Yeah, sure. I agree. I will raise the question tomorrow.
Thank you. Talk later.
No problem.
Yeah.
Bye.
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 Bye-bye.